All right, so for those of you who had a little bit of difficulty with our assignment yesterday, I'm going to do a couple of these problems to hopefully clear up any misunderstanding. So hopefully you can get that to me when you are able to. We remember that when finding the perimeter and area of a figure in the coordinate plane that is not a regular figure, or if it's a figure with not that doesn't have right angles such that they're going completely up, completely right, etc. We have to effectively assume those lines, imagine those lines along it, connected to it, such that it creates ways of finding those dimensions. So what I'm going to do now is exactly that. And that this process is called triangulating. So I'm going to do that everywhere I can here. Thankfully, I have red lines. So like this W here, I'm going to make a vertical line from this T down to where W is. Same thing with W down to, well, this point here doesn't have a name. Let's give it a name. Let's see, WTU, let's call that V. I'll put a, where's the best place to put it? Let's put a V right there. And do the same thing here. So I've effectively made a right triangle from like that is now TW and this point here. And with a right triangle, I can find this length by using the Pythagorean theorem. This squared plus this squared is equal to this squared, right? So I'm going to do the same thing for every line on this shape, on this figure, whatever you want to call this. You can call it a kite effectively. Let me use some different colors here. So I'm going to use that. Let's go blue for this line. Whoops, I'm still on the horizontal lines. Let's make this vertical. And do the same thing right here for this long line here. So if we don't have a horizontal or vertical line, we need to draw one in order to be able to better digest this information. We got two more to make. Right there. And come on. Oh, that didn't work. Right there. Okay, so now what I'm going to do is write down all these measurements, right? I have a lot of lines, but not a lot of information about them. Please click the pen. Oh, please don't not respond. Okay. Okay. What color should work for this? I'll go maroon. All right, so each of these lengths I'm just going to count out. And we're going to see that we can do that even if we can't count it out, but we have the coordinates for each. So let's see, this red line here is 1, 2, 3, 4, 5, 6, 7 units. This here, you can see it goes from 0 to -7. That's also 7 units. This guy here is 1 unit. This guy here is 2 units. This guy here, oh goodness. Well, it's this 7 from before plus 1, 2, 3, 4, 5, 6, right? 7 plus 6. This thing is 13 units. I know this is 2 units. This is 1, 2, 3, 4 units. Let me make this a bit smaller. And this last one here, I can just tell you right now, I know it's 10 units. And how do I know that? Well, just from what we learned earlier from composite figures, it's going to equal this length plus this length. This is 7 plus 1 plus 2. That's 10. We can also count that out, and I'll promise you you'll get 10. Okay, so in order to find the perimeter of this, we have to use Pythagorean theorem 4 times. And I'll show you how. 1 to find this side with this triangle. 1 to find this side with this triangle. 1 to find this side with this triangle. Sorry, my accuracy is terrible. And the last one to find this side with this triangle. These are all right triangles, and we know 2 of the 3 sides, so we can easily find that. So let's do that. We know in each of these, the side that we're missing is the hypotenuse. So I'm just going to leave this in the form of, well, we know a squared plus b squared is equal to c squared, right? We're looking for c squared in each of them. So in this guy here, we have 2 squared plus 10 squared is equal to c squared. Well, let's do some math. 2 squared is 4. 10 squared is 100 is equal to c squared. So 104 is equal to c squared. So this side would be, so to find c, we just square root both sides, right? So the square root of 104, which is just over 10, but we're going to leave it just as the square root of 104, is equal to c. I'm not going to name these different things. I'm just going to label them. So this one is equal to the square root of 104. Let's move on to the next one. This computer is so slow. Let's do this triangle, 4 and 7. We know 4 squared plus 7 squared is equal to c squared. 4 squared is 16, 7 squared is 49, so c, then that's equal to c squared. Well, what's 16 plus 49? I believe it's 65. Yes, 65 is equal to c squared. Square root both sides. Whoops, square root 65 is equal to the square root of c squared. So we'll say c is equal to the square root of 65. And we're just going to stop there. Sorry, it's not c squared, it's just c. We're not going to say, oh, that's a little bit bigger than h. We're just going to stop there. Square root of 65. Now let's try for this 7 and 1. One squared plus 7 squared is equal to c squared. This should, I mean, I'm doing all these, but they should all be digestible for you all. So 1 squared is just 1. 7 squared is 49 is equal to c squared. 50 is equal to c squared, just basic arithmetic. So that means I'll just say square root of 50 is equal to c, right? Which we know is just over 7, but we're going to say it's just a square root of 50. So I'll write that, square root of 50. One more, we're almost there. Okay, last one. This guy here. 2 squared plus 13 squared is equal to c squared. So that means 2 squared is 4. 13 squared is 169. That's equal to c squared. So this is 173 is equal to c squared. So that just means c is equal to the square root of 173. So what we'd say, if we wanted to be exact, which that's the point of math. Of course we can round, but why do that when we can do better? We'd say the perimeter is equal to the square root of 104 plus the square root of 65 plus the square root of 50 plus the square root of 173. These do not, we don't add these like within a square root. We don't say like the square root of 104 plus 65 plus 50 plus 173. You'll get a different answer. So you don't put them all under one square root. You just stop there. That's our perimeter. That's our perimeter. Now, to find the area of all this, we would, if we were asked that, we'd still need to triangulate all these, but we don't need these, we don't need to use Pythagorean theorem. So I'm going to erase these values in here because we don't need that. Let's shift gears to area. Let me go to a highlighter. So the area is all this, right? Well, how do we find that? Sorry, it goes down there too. I don't want to make it ambiguous though. Well, there's a few ways we can do it, but I think the easiest way, since we've already done this triangulation, is to do this. Is to find a bigger area and subtract out the parts that are not part of it. So I'm going to find the area of this rectangle and the area of this rectangle. I'm going to find two areas and then subtract out the parts of this area that are not part of our figure. So like I'm going to subtract out this area, subtract out this area, subtract out this area, and subtract out that area. So we're finding the area of two rectangles here, and then subtracting out the area of 4 triangles. And these are exactly the triangles that we made, right? So it's very convenient that we already have their measurements. So let's do that. Erase. I want to erase my numbers though. All right. So let's see. Let me draw a dotted line. So we have rectangle 1, I'll call it that, and rectangle 2. Let's call this R2, let's call this R1. Rectangle 1, well, area is just length times width. We have a length of 1 plus 2, which is 3. Or sorry, that's a width, that's the shorter side. A width of 3, a length of 13. Area of R1, I don't expect you to use this notation, I'm just doing it for purposes, for reasons. This area is 13 times 3, right? Which is 39 units squared. The area of rectangle 2, well, we have a, I erased this guy. 1, 2, this is 4. We have a length of 7 and a width of 6, which equals 42. Whoa, 42 units squared. Well, 39 plus 42, this total area is 81 units squared. We're gonna place that aside. Can I write up there? I think I can. 81 units squared. It's gonna be, then we're gonna subtract these 4 triangles, right? Subtract the area of these 4 triangles. Thankfully, with triangles like these, we can find their area because we have a base and a height. In order to find out what the base is, we need to find a vertical height from that, meaning a right angle height from that. Thankfully, we have that in all of these, right? So let's call this triangle 1, 2, 3, and 4. Area, remember triangle area is base times height divided by 2. So for triangle 1, 7 times 4 divided by 2. Triangle 2, I'll just list all these before I do the math. Triangle 2 area is 10 times 2 divided by 2. Triangle 3, and this is area in each of them. I'm just not writing area. Triangle 3 is 2 times 13 divided by 2, and triangle 4 is 1 times 7 divided by 2. So triangle 1 area is, well, 7 times 4 is 28, divided by 2 is 14 units squared. I'm not going to write units squared right now. Triangle 2 area is 10 times 2 is 20, divided by 2 is 10 units squared. Triangle 3, the area is, well, 2 times 13 is 26, divided by 2 is again 13. Just this 2, you can also think of it as the 2 on the top and the bottom cancel, 13 units squared. And then triangle 4, the area, well, 1 times 7 is 7, divided by 2 is 3.5 units squared. So let's add all these up. 14 plus 10 is 24, plus 13 is 37, plus 3.5 is 40.5. So what we learned is that our area is this 81 minus all that. And it happens to be exactly half of it in this case, 40.5 units squared. We're going to do one more of these. Now, when we don't have a grid in front of us, but we have the coordinates, we're going to treat it in the same way. And I think a couple of you had issues with that or difficulties, and that's okay as well. Like for right here, we're not going to, this is a trapezoid here for this shape. We're not going to deal with it like that. We're going to deal with it with triangles. And the way we do that, if we wanted to, would also be to triangulate. Well, how do we find these lengths then? Let me change it to red. That's 3, -5, that point. I'm going over it. Well, we can tell with the coordinates. So like when I'm drawing a line straight down here, we're given already that our x coordinate, our lateral coordinate, is -4. So when I'm going straight down, I'm going to be still at -4 something, right? So I'm just going to be at -4 until I get to this y value down here of -5. So it's the point's -4, -5. Well, how long is this then? Well, if we're going straight down, we only need to compare the y values. From 1 to -5, how much have I moved? 6 units. Same sort of thing with here. I need some water. Let's do this guy first. Here we are at the y coordinate of -5, and here we're also at the y coordinate of -5. So here I only move laterally. I'm only moving from this -4 to this -2. So we know this length is 2. Same sort of thing with here. If let's see. Let's take a look. If I'm at 5 and I'm going down here, I'm staying at this 5 as the x coordinate. If I'm going straight down, I'm not moving left or right. I'm staying at this x coordinate of 5. I want to compare these y values here, this 1 and this -5. So I'm going to move these 6 units until I'm at this point 5 and -5. The same sort of thing when I'm moving from this 5 to this 3 at -5. I'm only comparing one coordinate at a time. This guy here is 2. So let's see what we can do to fill in the rest of these lengths. I think And getting these lengths makes it really helpful for everyone. So let's see, this guy here, we want to only compare the x units, right? The x measurement. From -2 to 3, this thing is 5 units, right? This guy here, we're at the height of 1. We don't need to, so this 1 we can effectively disregard right now if we wanted to. From -4 to 5, how much do I move? 9 units. Let me erase that though. 9 units. Same sort of thing with here. The 5 is the x unit. We're only moving up and down though. We don't need to worry about that. If we're moving from 6 to 1 or from 1 to 6, we move 5 units. And it's the same thing there. You can probably already tell it's a rectangle. Here, we have to be a little bit careful. If we know this is a rectangle, we know this here is going to be 9, but this here is going to be something different, right? This here, if we're moving from -4 to 2, we are not moving 9, we are moving 6. Lastly, from this 6 to this 9, again, we only got to think about 1 unit at a time. We're moving 3. So now when we have all these units, we do the same procedure with Pythagorean theorem to find this length, and this length, and then we'd add them all up. An area would be the same sort of thing. If you want me to go through that, I can, but I'm out of time right now. I hope this helped.